This begins the lecture notes for Chapter 3, Section 3. And in Section 3, we deal with Newton's third law. Newton's third law of motion describes action-reaction pairs this way. When one object exerts a force on a second object, the second one exerts a force on the first that is equal in strength and opposite in direction. It's the whole idea behind the Newton's cradle on my desk that you all been playing with all year. Newton's cradle, you grab one ball in the mix and you let it go and one ball comes off the other side. Equal and opposite reactions. Action and reaction. When a force is applied in nature, a reaction force occurs at the same time. When you jump on a trampoline, for example, you exert a downward force on the trampoline. Simultaneously, or at the same time, the trampoline exerts an equal force upward, sending you high into the air. According to the third law of motion, action and reaction forces act on different objects. Thus, even though the forces are equal, they're not balanced because they act on different objects. We'll look at that here in a second. An example of this is a swimmer acts on the water. The reaction of the water pushes the swimmer forward. A net force or unbalanced force, and this is kind of bringing all of those unbalanced and balanced forces together, acts on a swimmer so a change in his or her motion occurs. In a rocket engine, burning fuel produces hot gases. The rocket engine exerts a force on these gases and causes them to escape out the back of the rocket. By Newton's third law, the gases exert a force on the rocket and push it forward. Momentum. A moving object has a property called momentum that's related to how much force is needed to change its motion. The momentum of an object is the product of its mass and velocity. And at this point, you should be thinking ahead, what's the formula for momentum? It's a product of its mass and velocity. Momentum is given the symbol P, and I guess it's given a symbol P because M was already taken. Can be calculated with the following equation. Momentum in kilogram meters per second. Now, we saw a term that was kilogram meters per second squared, which is a Newton, but this happens to be a kilogram meter per second. Momentum equals the mass in kilograms times velocity meters per second, and you arrive at a formula P equals M times V. You notice in this formula one thing they left out is the direction. Momentum should have a direction. So this statement should be P equals MV in a given direction. The unit for momentum one more time is kilogram meters per second. Notice that momentum has a direction because velocity has a direction, which they failed to illustrate in the equation here. Force and changing momentum. Recall that acceleration is the difference between the initial and final velocity divided by the time. And if you remember correctly, we had acceleration A equals d sub f minus d sub I all over t. Formula for acceleration. Okay. Also, from Newton's second law, the net force on an object equals its mass times its acceleration. Remember that formula? F equals M times A. Hard for me to draw an A. This one I'll put up one more time. Acceleration equals d sub F, final velocity minus initial velocity divided by the time. Okay. By combining these two relationships, Newton's second law can be written in this way. force, and again, remember this is Newton's second law, the second law. Newton's second equals force equals mass times the final velocity minus mass times initial velocity divided by t, by the time. This equation, mvf, is the final momentum, because if you look at this part of the formula, this is the formula, this is how you solve for p, or the momentum, and this is the initial momentum. So you could say that this is p sub f, and this is p sub I, the initial momentum. The momentum of an object doesn't change unless its mass, velocity, or both change. Momentum, however, can be transferred from one object to another. The law of conservation of momentum, and we've seen several laws already this year. This is a new law. The law of conservation of momentum states that if a group of objects exerts force only on each other, their total momentum doesn't change. It's related to the law of conservation of mass, the law of conservation of energy. It says basically we can't create momentum. We can only, in this case, transfer it from one object to another. The results of a collision depend on the momentum of each object. In this illustration, when the first puck hits the second puck from behind, it gives the second puck momentum in the same direction. So in this illustration, this puck hits this one, it's going to give it momentum in that direction. Give it momentum. If the pucks are speeding towards each other with the same speed, the total momentum is 0. If this puck and this puck hit here, they should both stop right there if they're traveling with the same momentum. This concludes the lecture notes for section 3. Again, we'll go through these questions in this lecture, but your assignment, besides listening to these lecture notes, will be to complete the online Chapter 3, Section 3 review questions and post your results, just like last semester, into the Section 3 results block that you'll see on that page. Question number 1 of Section 3. According to Newton's third law of motion, what happens when one object exerts a force on a second object? The answer, according to Newton's law, the second object exerts a force on the first that is equal in strength and opposite in direction. Question 2. The momentum of an object is a product of its choices are mass and acceleration, mass and velocity, mass and weight, or net force and velocity. And in this case, P equals M times V, so it's mass and velocity, letter B. Question 3. When two objects collide, what happens to their momentum? And according to the law of conservation of momentum, if objects in a collision exert forces only on each other, their total momentum doesn't change, even when momentum is transferred from one object to another. So basically, you just give the other objects the momentum. You don't create or destroy, it's just transferred or changed from one object to the next. And this will conclude the lecture notes for Chapter 3, Section 3. Again, it'd be a good idea to go back through all of the lecture notes, go back through all of the review exercises online. I only assigned the last one of Section 3. It's a good idea to go back and also look at Section 1 and 2.